transformer, or CT, is to take a current flowing through a wire or cable and step it down to a magnitude that a protective relay can measure. A primary characteristic of CTs is their conversion ratio. In this example, our conversion ratio is 100 to 5, meaning that if 100 amps are passed through the primary phase wire, the CT will scale this down to 5 amps and direct it to the relay via the secondary windings. The 5 amp measure is known as the secondary nominal current. If a fault were to occur on this phase that increases the primary current to 200 amps, then 10 amps would be passed to the relay through the secondary windings consistent with the ratio. CTs have two types of secondary ratings, 5 amps and 1 amp respectively. 5 amps is typically the North American standard, while 1 amp is used in Europe and Asia. Primary ratings are available in various different levels, for example 100, 150, 200, etc. Types of CTs. A common current transformer construction is one in which the power system phase wire is passed through the hole in the center of an annular core or ring, which is called a window. This forms the primary winding. A second insulated wire is then wound around the core and then brought to the relay for measurement. This is known as the secondary winding. A CT with this type of construction is typically referred to as a toroidal or donut style of CT. A bushing type CT refers to a CT that is built into another power system device, such as a breaker. Terminals are provided on these devices to permit connecting the CT to a relay. A bar type CT has a solid bar that passes through the annular core to form the primary winding of the CT. The primary phase wires of the power system are then connected directly to these bars to complete the connections.